Welcome, dear students. Welcome to the Gradeup, the India's largest e-learning platform. Dear students, come on. Yes, come on, join the session. Yes, dear students. So, this is the Gradeup, India's largest e-learning platform. And dear students, we have started our series, that is the crash course on production engineering, within these 8 sessions. So am I audible and visible to you guys? Show me your presence in the chat box. Yes, please. Come on, join the session very fast. So in the today's session, dear students, we will be having the questions on the metal forming. Right? Today we will be having all the questions related to the bulk deformation processes. And it will be covering all these bulk deformation processes. In the tomorrow's session, we will be solving the numericals questions on the sheet metal working. Yes, dear students, please let me know, am I audible and visible to you? Good evening, Prashant. Pratik, very good evening, dear. Yes, anyone is there? Anyone is there? So please join the session very fast. So Pratik, am I audible and visible, dear? Brahmesh, good evening. So come on, ask your friends to join the session very fast. Come on, join the session very fast. So dear students, today we are going to discuss about the metal forming. Okay, the numericals on the metal forming. Okay, and tomorrow we will be covering the sheet metal working topic, that is the numericals on the sheet metal working. Okay, Yes, Pratik. That is the thing only. Tomorrow we are going to discuss about the sheet metal working. No, sorry, the bulk deformation processes. And tomorrow will be the sheet metal working. Yes. So where are the people? चलो आ जाओ भैया, आ जाओ जल्दी से, चालू करना है मुझे, जल्दी आ जाओ. Show me your presence in the chat box. Come on. Once again, welcome to the Gradeup. So shall we take the question? Shall we start? So before that, this is about me, dear students. I am Onkar, having done more than 10 years of experience for teaching GATE and ESE. I have mentored more than 10,000 number of students, right? And my area of expertise are production and industrial engineering, fluid mechanics as well. Kalpana, welcome dear. चलो आ जाओ भाई, जल्दी आ जाओ. So we want the numbers. Okay, this is for you only, guys. Take the advantage of this. Okay, so dear, take the first question. A 4.5 mm thick aluminum alloy strip is rolled to a thickness of 3.5 mm using the pair of steel rollers of diameter 250 mm. The tensile strength of the aluminum alloy is 250 megapascal. Then question number 1, the minimum coefficient of friction between the workpiece and roller for maximum reduction per pass, the angle subtended by the contact zone at the roll center, and the number of passes required to complete the operation. So this is the question on rolling, dear students. This is the question on rolling. I hope you know the formulas of rolling. Okay, rolling के formula सबको पता है क्या? चलो आ जाओ and be there with the calculators. You are going to tell me the values. You will calculate that so that the time will be lesser to solve the questions. चलो आ जाओ भाई. So बताओ यहाँ पे H ओरिजिनल क्या दिया है? 4.5 mm की क्या है आपके पास शीट है. You have reduced this sheet to the H final of 3.5 mm by using the roller of radius 125 mm, that is the diameter of roller is 250 mm is given. Okay, sigma y yield strength of that material is 250 megapascal is given. So what they are asking to calculate, first thing is what? The minimum coefficient of friction when we take into account maximum possible reduction. So what is maximum possible reduction? So delta H max, you know, it is equal to mu square times R, isn't it? So delta H here how much? Delta H कितना है भाई? 4.5 mm से लेके 3.5 mm तक ये ड्राफ्ट है is equal to mu square times radius of the roller कितनी है? अगर 250 mm diameter है तो क्या है? It is 125 mm will be the radius, isn't it? So tell me the mu value. So it will be 1 divided by 125. Root over the answer, it will be 0.089. Check it out. Yes, dear students, please calculate the mu value 0.089. Have you got this value? Yes, Sudhir, very good, Sudhir. 0.089, this is the coefficient of friction for the maximum possible reduction. Okay, very nice, very nice. Kalpana, very good. Come on, participate. Don't only see the session. Participate into the session. Practice it here only. Next thing, what they are asking, the angle subtended by the contact zone at the roll center, that is nothing but the bite angle. Bite angle. Okay, alpha you want to calculate. Yes, Adarsh, very good Adarsh. Come on, join the session. If this is the roll or these are the rollers and this is the angle, this is our bite angle. Okay, this was 4.5 mm. After having the passing through the rolls, it is. Hello Nishant. So this angle alpha. So calculate this alpha. So you know this is what the radius of the roller r, and this is our actually what LP, length of arc of contact. This distance I am saying, length of arc of contact LP. How to calculate this alpha? You know very well, that is delta H is equal to 2r into bracket 1 minus cos alpha. Isn't it? Delta H is how much? 1 is equal to diameter is how much for the roller diameter? 250 into bracket 1 minus cos of unknown angle alpha. So tell me, so it will be 1 minus 1 divided by 250, isn't it? 1 minus answer 1 divided by 250, 1 minus answer, shift cos inverse of answer. Will it be 5.12 degree? 5.12 alpha I am calculating 5.12 degree. So it is in degree. If you want to convert it into radians, multiply by pi divided by 180, it will be radians. 5.12 degree, it will be the this bite angle alpha or angle of deformation. Okay, you will get in the rolling operation. Yes, come on, join the session. Kalpana very good, Pratik very good, Sudhir very good. Okay, okay, chalo bhai, aa jao. Be there in the large numbers so that all you get benefited. Others very good, others. Now the third thing what they are asking, the number of passes required to complete the operation. How to calculate the number of passes? So dear, number of passes कैसे calculate करते हैं? Number of passes how to calculate? Number of passes is nothing or equal to the draft divided by the maximum draft per unit or per unit of passes. Okay, so maximum draft in a per pass, that will be the denominator here for calculation of the number of passes. Delta H divided by maximum possible reduction per pass. Per pass. So definitely you will be having delta H is how much here? Yes. डेल्टा एक्स मैक्स कितना था? How much? So 1 divided by 0.9, it is actually 1 only, no? Mu square into r, that is our H max. Yes, 1 only. So 1 only, no any issue. So it will be only 1 only. Yes, that is 1 only. So 1 divided by 0.99 is almost equal to 1 pass only. Okay, yes, that is correct. Now no need to go in that details. If we have that large difference, definitely we will get there between delta H and delta H max, that is maximum possible reduction per pass. Then you will get something value more than 1. Okay, no issue. Take this question. In a wire drawing operation, diameter of the sheet of a steel wire is reduced from 10 mm to 4 mm. That is, D initial is given as 10 mm. Okay, and final diameter of wire is given as 4 mm. Right. The mean flow stress, sigma flow mean is given, that is 450 megapascals. The coefficient of friction between the die and the rod, mu, is given as 0.18, and the diangle 2 alpha given as 24 degree. Okay, so diangle given, this is 2 alpha given, so alpha will be 12 degree, half the diangle. The speed of the drawing, the velocity or speed of the drawing given as 600 meter per minute. Okay, and they are asking, hi Vijay, how are you? Yes, Sudhir, number of passes is 1 here only, no need to calculate. That is why I am moving to the next question. Yes, tell me. Now you know that, dear students, there are the two conditions we are having for calculation of the load or force in the wire drawing operation. Even in the extrusion process, even in the tube drawing process, we are calculating with the ideal condition, with the ideal case of deformation, where you need to calculate the drawing stress. You can simply say sigma y ln of A original divided by A final. But dear students, here the coefficient of friction mu is given. Okay, the half the diangle is given, so definitely the case is what? The second case, that is the force calculation with the force and redundant work, isn't it? Redundant work, that we have to take into account. Redundant work, that is useless work, it is not supporting for the any deformation, so that is a redundant work, you know very well. Now you know that in such a condition, whenever the friction is given there, whenever the diangle is given there, you need to calculate the sigma d drawing stress is equal to sigma y, or your flow stress of the material is equal to sigma d is equal to sigma y into bracket 1 plus b divided by b into bracket 1 minus A final divided by A original to the power b. Okay, no need to worry. Simply if they want to ask, sometimes they give this formula, otherwise you know very well, you can derive it very well. There is no any back stresses or pulleys there, definitely, so that term I have not written here. Directly you will take the sigma d is equal to sigma y into bracket 1 plus b divided by b into bracket 1 minus final cross sectional area divided by initial cross sectional area to the power b. And where b you know very well, b, what is that? B is equal to mu cot alpha. So calculate this b first. B is how much? 0.18 cot of 12, 0.18 divided by tan of 10. That will be 1.02. Please tell me. Is it 0.84? B is equal to 0.84, please. Now sigma d is what? Flow stress is how much? 450. So 450 into bracket 1 plus b, that is 1.84 divided by b 0.84 into bracket 1 minus, I can write A original by, or sorry, A final divided by A original is equal to what? Pi by 4 D final square divided by D original square, isn't it? So that will be D final divided by D original square, isn't it? So I can write 1 minus D final diameter is how much? Final diameter 4 mm, initial 10 mm. So 4 divided by 10 to the power 2 into B is what? B is what? 0.84. अरे भाई कोई है कि नहीं वहां पे? आ जाओ भाई, बताओ मेरे को कितना आया सिग्मा डी? व्हाट इज द वैल्यू ऑफ सिग्मा डी? There are so many people but they are doing nothing. Come on, join the session, do the calculation and tell me the values. See, I am doing the calculations. 0.84 multiplied by 2, 1.68. 4 divided by 10 to the power 1.68. 1 minus answer into 1.84 divided by 0.84 multiplied by sigma y 450. So 774, please check it out. 774.26 megapascal. See, I am doing the calculation with you. Okay, so it should be the live. Okay, 774.26. Kalpana, tell me the answer. Vijay, Sudhir, Pratik, what are you doing? Be there and write the values. Participate actively. Make the practice here itself. See, yes, if I am wrong, please tell me what is the correct answer to write here. Shivani, whether it is correct? I want the sigma d. ड्रॉइंग स्ट्रेस पहले तो बताओ मेरे को कितना आया, पहले ड्रॉइंग स्ट्रेस तो बताओ, स्टेप बाय स्टेप जाएंगे, फाइनल आंसर हम देखेंगे एट द एंड। यहाँ पे रेस नहीं अपनी, यहाँ पे अपना प्रैक्टिस अंडरस्टैंडिंग है, वो एग्जामिनेशन में रेस होगी। सो 4d, ओहो d फाइनल 4 डिवाइडेड बाय ओरिजिनल 10 टू द पावर 1.68, 1 माइनस आंसर into 1.84, 1 plus b by b is 0.84 into sigma y sigma flow 450. I hope 774 is correct. Okay, when I get the sigma d value, how to calculate force? Now dear students, you know very well, in the wire drawing operation we are pulling this wire, so at the end this is the final cross section area which is important for us, isn't it? And we are applying the load here, right? So pulling is there, tensile stresses are produced, you know very well. So sigma, if you want to calculate the force, it will be the drawing stress into which area? Final cross section area, isn't it? So sigma d is how much? See, I am getting here 774.26 into pi by 4. Final diameter is 4, no? 4 mm. So tell me, multiply by 0.25 pi into 60. Please check it out, force will be how much? So I am getting 9723 newtons, that is the force. Okay, and once I get the force, the power will be what? The velocity or force into velocity. Okay, so force is how much? 9723 into velocity is how much? How much the velocity there? 600 meter per minute. So it should be, to get the power in what? 600 meter per minute. So divided by 60 minutes, it is seconds. So tell me what is the value? So it will be meter per second. Very good, very good, very good. So I am getting the value 97 kilowatt. 9723 multiply by 600 divided by 60. 97230. 97230 watt. Okay, and in which term they are? In horsepower. In horsepower, you know that 1 horsepower is equal to how much watt? 1 HP, you know, that is 746 watt. So if you divide it by 746, so it will be how much? 130. It should be 130. Check it out. In terms of HP, please check it out. The force is okay, 9729 is okay. So 97.23, that is correct, kilowatt. Yes or no? And we know that 7, yes, Pratik, very good, 130.3. Shivani, what is the answer actually? Kalpana, so that is the thing, I get confused here. You are saying how much? 0.8 something you wrote. Prashant, very good, Prashant, very good, 130.4 horsepower. Shivani, yes, 130 horsepower, that is correct. Pratik, very correct, power, that is correct. Sudhir, check it, your answer, Sudhir. 1 horsepower dear is equal to 746 watts. Isn't it? So how much power is there? Power requirement for that motor 130, you take rounded value 130 HP. That is correct. Means we have calculated the force here, that is also correct. This is also correct. Okay, this power is also correct here in watts. That is also correct. Okay, very good, very good. Take the next question. Take the next question. A shaped wire is drawn from the annealed 3 mm diameter stainless steel wire. Okay, a shaped wire is drawn from annealed. From means original. Okay, so original diameter how much? 3 mm, and cross section area of the shape that we are going to obtain final area is what? 5 mm square. So it will be equal to pi by 4 d final square. So tell me what is d final? That is 20 divided by pi root over answer, and root of the answer is 2.81. Tell me a final or d final will be how much? 2.81. Okay, oil based lubricants used to give the coefficient of friction mu is how much? 0.005. Included angle, included, that is 2 alpha is given 12 degrees, so alpha is equal to 6 degrees. Drawing speed is given, velocity is given 2 meter per second. Again calculate the draw force and the power requirement. Come on, do it very fast. So please do the calculation correctly. I don't want any mistake there. So again you note to, again friction is there, angle is given, definitely it is sigma d is equal to sigma y. Oh, you have to take here flow stress. Please write here 450 for same exam. Okay, $2.53 आ रहा है. Okay. So 5 into 4, 20 divided by pi, 20 divided by pi, root over answer 2.52. Yes, 2.52. That is correct. That is absolutely correct. So I want the people like you. .5. Very good, excellent. Yes, 2.52 आया. Now do the calculations. Sigma d is equal to sigma y into bracket 1 plus b upon b. जल्दी करो. Into bracket 1 minus d final divided by d original to the power 2b. You know this. So b कितना आया? Mu 0.005 ना, बहुत कम है. Mu into cot of 6. So 0.005 divided by tan of 6. So 0.047. B आया 0.047. Okay, what is mean by this, Harshvardhan? So tell me what is sigma d now. Sigma y is 450 into bracket 1 plus 0.047 divided by 0.047 into bracket 1 minus what is d final 2.52 divided by 3 to the power 2 into 0.047. Tell me the sigma d value. Sigma d बताओ. Harshvardhan, what is meaning by this dot? Straight line means dead. Sudhir, try to tell me the stepwise things. Sigma d पहले बताओ Sudhir. Sudhir, tell me what is value of sigma d. Into 2. Okay. 2.52 divided by 3 to the power answer 1 minus answer into 1.047 divided by 0.047 into 450. Is it 165? 165 megapascal. Please let me know 165 megapascal sigma D. Then I will move ahead. Check it out. (165 megapascal sigma D). Okay, that means this is correct. Shivani, whether it is correct? Kalpana, check your answer. Sudhir. So sigma D I have got here. Now when I get the sigma D, definitely I can get the force. The force in the drawing operation, force F is equal to, or load in the drawing operation, that will be sigma D into A final. Okay, 165. 165 have taken rounded value. Okay, so sigma D is 165 into pi by 4. Final diameter is how much? 2.52 whole square. So how much it is? 2.52 square into 0.25 pi into 165. 833 or 823 Newton. 823 Newton. That is the force. Okay, that is okay. 823 Newton. Very nice. Okay, and when you get the force, power will be how much? Force into velocity. So power is force into velocity. 823 into velocity. It is okay. It is a force. It is not a very precise dimension. It is over a range. That is correct. This is a force into velocity is how much? 2 meter per second. 2 meter per second. 2, that is force is Newton into meter per second. That will be joule per second, which is nothing but the watt. So 823. What happened, Pratik? How much you are getting? 812. How it will be more than the flow stress? Pratik, you check your answer. I hope this is correct. Yes, how much watt? Say 823 into, so 1646. 1646 watts. Okay, 1646. That is correct. Yes, Pratik. Now it is okay. Pratik, very good. Sudhir, very good. Kalpana, very good. Very good. Take the next question. Yes, correct, Sudhir. Flow stress is 162. That is correct. I hope this question is clear. Very easy question. Go for the next. A solid cylindrical steel workpiece, 300 mm diameter and 2 mm height. No issue. Calculation, it is okay. These are the stresses. These are the drawing stresses. These are tremendous stresses. In bulk deformation, no need to worry about that much the precise values. Okay, or after what is there after point, no need to worry about that. These are the loads, very huge loads, tremendous loads are there in the deformation. No issue. You can round it off. Fine. So here solid cylindrical diameter कितना है पहले का भाई? 300. D original how much? Saran, good evening. 300 millimeter, and original height is how much? 200 mm. The component is reduced by 75% in height. Okay. So 75% reduced by 75% मतलब 200 into 0.25, that is 50%. Okay, isn't it? So H final will be how much? 50 mm. When you reduce it, not reduced to 275, it is reduced by 75%, मतलब 100 minus 75, that is 25. You have to multiply by 0.25 to the original height, isn't it? So you are reduced by 75%. So you will be getting, when you reduce by 75%, it will be 50 mm. Okay, then tell me what is the D final at that time? Yes, Kalpana, that is correct. Final diameter, apply the volume constancy A naught H naught is equal to A final H final, that is pi by 4 D original square HO is equal to pi by 4 D final square H final. So D final कैसे निकालोगे? HO divided by HF root over answer into DO, that will be your DF, isn't it? So tell me how much it is. D original 300 root over H original 200 divided by 50. Tell me what is the answer. Whether it is 600, very good, 600 mm, very good Sudhir, very nice. So you get the value, how much for the final diameter. So initially see, if you are having this is a moving platen for the forging, and this is the stationary die or platen, right? So you are having some initial diameter, say this is the original height, this is the original diameter, and when you apply the force by this moving platen, so suppose your die is now applying the force and it is here. So now this HF, you know it is how much? 50 now, and definitely there will be the increase in the diameter. Now it is going to be, say, 600 mm, isn't it? Very nice. So what they are saying, okay, assuming the flow stress of the material 850 megapascal and coefficient of friction sigma flow 850, and what they are asking or saying that the coefficient of friction mu is equal to 0.3, then the force at the end of the stroke, at the end of the stroke. Dear students, you know that in the forging operation, this is a very important assumption, that wire diameter increases, that is volume constancy is valid. Okay, you know that if you analyze the forging operation, it will be analyzed that the sticking friction condition and then sliding friction condition, isn't it? Definitely when you are suppressing that height, so where it will go for compensation, that is it increase in the diameter. Kalpana, that is very simple thing. If in the metal forming operation the volume constancy is always valid, that is if you have the initial volume of the raw material which is always equal to the final volume or the intermediate volume of the product. Okay, so definitely diameter तो बढ़ेगा ना. अगर ये हाइट रिड्यूस होगी तो डायमीटर वॉल्यूम जाएगी कहाँ? सो वॉल्यूम कहाँ पे जाएगी? इट विल इंक्रीज द डायमीटर. दैट इज वेरी बेसिक थिंग. ओके, सो प्लीज रिमेंबर दिस. सो हाइट बढ़ेगी, डायमीटर हाइट घटेगी, डायमीटर बढ़ेगा. अगर डायमीटर बढ़ेगा तो हाइट क्या होगी? डेफिनेटली घटेगी. समवेयर इट मटेरियल हैज टू गेट कॉम्पेंसेटेड, either in terms of the diameter or in terms of the height. So there is one important assumption, dear students. Whenever the force applied in the forging operation, we are taking it is maximum at the end of the stroke, at the end of the blow. And whenever the coefficient of friction is given in the question, dear students, We know the formula, very important formula, that is the force in the forging operation is given by sigma flow or sigma y into A final into bracket 1 plus what? 2 into mu times R final divided by 3 times H final, isn't it? Right? So this is very important formula. If not, please take it down, note it down. This is very, very important formula. So here sigma y, sigma flow is how much? 850 into final cross sectional area pi by 4. What is df? Df is 600. Yes, df is 600 square into 1 plus 2 times mu is how much? 0.3. RF final radius is how much? 600 divided by 2, that is 300 divided by 3 times what is H final? Final height, you know, that is 50, isn't it? Calculate and tell me the answer. So if I calculate 2 into 0.3 into 300 divided by 150 plus 1 into 850 So how much it is? 528 meganewton. 528 meganewton. So my answer is coming as 528 meganewton. So this is the force. This is the how much? So this is the maximum force in the entire forging operation, which is at the end of the stroke. Please remember, at the end of the stroke. End of the stroke. So 528 megapascal. Yes, 528 megapascal. It's not pressure. It is a force. 528 meganewton. Meganewton. That is correct. Okay. So this is how you can get the force in the forging operation. Whenever, please remember, whenever in the question of forging, coefficient of friction is given and they are asking the force at the end of the stroke. So this formula, please remember, this formula is very important. I hope you know this. Excellent. Pratik, what is the answer? Pratik, Sudhir, Saran, where are you? Shivani, Kalpana, what is mean by this 2 plus plus? 2 plus signs? Shall I go for the next? Now see, this is the question again. It is related to the loads, and but here no any coefficient of friction is given. A cylindrical billet of 200 mm diameter is being forged from 100 mm height to 60 mm at 900 degrees centigrade. The material have the constant flow stress of 100 megapascal. Find out the energy required for the deformation, and if 1200 Newton drop hammer. So this is the question on this, Chandru. So see this is the question. If not, mu is not given. So same, I have taken the same question. Don't worry. When the mu is not given, this is the question we are going to understand. Yes, Chandru. So see here, no any coefficient of friction is given. This is the ideal case. Actually, you simply have the original cross section, final cross section, multiply that cross section with the corresponding value of sigma y or average flow stress. Okay, you will be getting all these things, right? Very nice. So calculate, and what they are saying, if the 1200 Newton hammer, drop hammer is used to complete the reduction in one stroke, what will be the height of fall? What will be the height of fall? Right? So again, do the same work. Cylindrical billet of 200 mm diameter. So D original is how much? 200 mm. Okay, from height how much? H original is 100 mm. Check it out. 260 mm height, from 100 mm height to 60 mm. H final is given. It is 60 mm. Thank you, Sachin. Thank you so much. Okay, now tell me, H final is 60 mm. What is D final is there? No, D final is there. So calculate by the volume constancy. Please tell me, that is pi by 4 DO square. Okay, into HO is equal to pi by 4 DF square into HF. So tell me DF value. So I can write DF is equal to DO into what? Root over HO by HF. So tell me what is DO, that is 200 into root over HO is what? 100 divided by HF 60. So 100 by 60, 100 divided by 60, root over answer into 200, 258. Very nice, Sudhir. So DF is how much? 258.2 mm. Very nice. Now very simple thing, dear students. Now what is the F initial? What is the minimum force initial, which is minimum, which will be the flow or sigma y into A original. Okay, so sigma y or sigma flow, how much it is given? Flow stress of 100 megapascal. 100 into original cross sectional area, pi by 4. What is D original? D original 200 whole square. So this is the initial minimum force, that will be 200 square into 0.25 pi into 100. How much it is? F minimum initial, how much? Yes, that is correct, Sudhir. Yes, tell me how much it is, the energy or this force is how much here? I am getting 3.14 meganewton or 10 to the power 6 Newton. Okay, and what is F final minimum? It will be sigma y into A final. So it will be sigma y is how much? 100 into pi by 4. Final diameter 258.2 whole square. So 258.2 whole square into 0.25 pi into 100. So it will be 5.23 meganewton. F final minimum, it will be 5.236 into 10 to the power 6. Okay, when you are getting this initial and final minimum force, okay, then you will get the actual force or average force is what? The F initial plus F final, which are minimum divided by 2. So it will be 3141.59 plus 5236.03 divided by 2 in kilonewton if I write. So how much it is? 3141.59 plus 5236.03 divided by 2. So it will be 4188.81 Newton F average. And if there is a forging efficiency is given, so you can simply divide it by the efficiency, you will get the actual. So this is the kilonewton. I hope it is clear. I hope it is clear. Right. Once you get the forging force, dear students, okay, find out the energy required for the deformation. So energy, how to determine the energy? So force you got here. Now the energy is what? From initial height to the final height, you have deformed this given cylindrical workpiece. Okay, so initial height was how much? Initial height was 100 and final height was 60. 100 H final was 60 millimeter. So definitely work done you can calculate. Work done is equal to force, average force into the height HO minus HF, change in height. So how much the force? 4188.81 into 10 to the power 3. Okay, because it is in kilonewton, into 100 minus 60. These are millimeters, so definitely into 10 to the power minus 3 meter, so that I get work in terms of the joule, Newton meter. Okay, so multiply by 40 if I do, so it will be 167. How much it is? How much it is? Work done 167.55 kilojoule. 167.55 kilojoule. It's a kilojoule, right? This is the work done. This is the energy of deformation. Yes or no? Yes, Kalpana, very good. 167.3 kilojoule. So you are saying in joule, that is correct. Okay, I hope it is clear. Kilojoule, joule, not kilonewton. This is the work done. This is the work done. Newton into meter, which is nothing but the joule. Please remember this. Very good, very good. Now what they are saying, if we use the drop hammer of 1200 Newton, no? What they are saying, 1200 Newton for the same work done, and say this is our workpiece is here. So how much is the height? Okay, so from which height you are going to drop this hammer? So you know that this potential energy of this converted into this impact loads, isn't it? And yes, students, please remember that because of this impact loads are here, because in the case of the drop forging, we will be having this energy will be, or the force will be 2 times, isn't it? Yes, already done. See here the kilonewton was there, so I write here into 10 to the power 3 Newton, and this is meter. It was a millimeter, 100 millimeter, and 60 minutes, so into 10 to the power minus 3. So I have done it correctly, Pratik, I hope. 10 to the power 3 for it is a kilonewton. It was kilonewton, and it was in millimeter. Please check it out. Okay, tell me the height. So tell me if this work done is equal to what? Twice F into H, isn't it? So work done is how much, you know already. It is how much? 167.55. 167.55 into 10 to the power 3 is equal to the force or the load of the hammer is 1200 Newton into H. So tell me, divided by 2400, so it will be 69. How much? How much it is? 29 or 69? So I hope this is the beyond practical thing. Okay, this is beyond practical thing actually. Whatever the dimensions that we have here, okay, 200 mm diameter to the 100 mm height, 60 mm. Then if take here 12,000 actually, okay, not 1200, it is 12 kilonewton hammer, okay, 12 kilonewton draft hammer, because it is not a practical thing. Okay, if you do like this, it is 1200, no, it is 12,000 Newton, 12,000 Newton. Okay, yes, of course, in meter. So according to Pratik, what should be the answer? One sec, Pratik, I will check. See here, the forces was in, initially I write in meganewton, then I write it in kilonewton. So these are the forces, 4188.81, it is a kilonewton force. Okay, now this kilonewton force multiplied by this kilonewton means what? I have to multiply into 10 to the power 3 Newton. Okay, so same thing I have done here, 10 to the power 3. Okay, and 100 millimeter initial and final height 60 millimeters. So 100 minus 60, 40 millimeter is the change in height. Millimeter, it is millimeter, so definitely I have to convert it into meter. Okay, that will be into 10 to the power minus 3. Okay, Pratik. So see here, 10 to the power 3 and 10 to the power minus 3 get cancelled out. So we left here only 4188.81, okay, into 60, 100 minus 60, it is 40. So I have got here 167552.4 joules. Kalpana, please check the answer here. Sudhir, tell me whether it is correct. Now it is okay, nothing is wrong. So that will be 167.55 kilojoule. Same thing I have written here. And for the calculation of this work done, I again converted into the joule. So 167.55 instead of 1200 you take, there is a 12,000 Newton, because answer will be then not practical, but this can be practical if you have, yes, that is 12 kilonewton drop hammer, 12 kilonewton, that is correct. So 12 kilonewton means 12,000 Newton. So tell me, so it is not 69, it should be 6.9. It is practical thing, somewhat practical. Yes, that is correct. This height will be 6.9 meter. Are you getting my point, what I am saying, Pratik, Kalpana? Sudhir, yes, calculations are absolutely correct. 6.9 meter, because see, we have written here the work done in Newton meter. Okay, 6.9 meter, Vijay, absolutely correct. 6.9 meter, absolutely correct. Take the next question. I hope you will solve it by your own. This question. So this is a question on extrusion. Read the question and tell me what you are going to do for this question. And dear students, please be there in the huge numbers. Ask your friends to join the session. Can you solve this question? A cylindrical billet of 50 mm diameter and 100 mm length is extruded to final diameter 0.25 mm by using direct extrusion. The average tensile yield strength of the alloy is 120 megapascal. The die angle is 90 degrees and coefficient of friction between the die and the billet material is 0.1. Use Tresca's condition to take the value of maximum pressure due to the container wall friction. Find out the extrusion load in meganewton. So yes, dear student, we try to complete the questions on the bulk deformation, on rolling, forging, wire drawing, extrusion, right? So in the tomorrow's class, we will be looking for again the numericals, some nice questions regarding to the sheet metal working. Okay, and dear students, take this as a homework, take this as a homework. Take this question as also homework. This is another question, take it as a homework. So solve this question. Okay, a cylindrical billet of 90 mm diameter is extruded to a I section as shown in the figure. Total extrusion pressure is given as P sigma m into bracket 0.8 plus 1.2 ln of A original by A final, and calculate the extrusion load. This is also very good question, dear students. By the Johnson's equation, we can just, this is the Johnson's equation we are using for calculation of the load. Okay, right. So dear students, see, tomorrow again we are meeting at 7 p.m. yes, and we'll be discussing about the sheet metal working, of course. So do follow me on the Gradeup app, dear students, right? Do follow me on the Gradeup app and be there in the huge numbers, so that share this session, like this session. Sudhir, if you want the solution, you can ask me. I have to solve here. I will bring these two questions once again tomorrow. We will solve it. If you want, if you are not getting answer, then only I can solve. I hope you will get the answer only. Nothing is difficult there. Or if you want solution, I will put in the PDF. In this PDF only I will put the solution for the respective questions and I will upload that PDF. Okay, then it is fine. So thank you so much, dear students. Thank you so much for joining the session, and again we are going to meet tomorrow. Thank you Vijay, thank you Pratik, Kalpana, then Sudhir, all of you, thank you very much, and I am winding up this session. Thank you so much. Bye bye, good night, take care.